Good morning. Myself, I'm Dr. Sunil Kumar BS. In fact, I'm the professor and Dean Academics in GM Institute of Technology. Also, I'm looking after the Information Science and Engineering Department in GM Institute of Technology, Davanagere. Indeed, I'm very grateful to the VTU for having given me an opportunity to teach two chapters in the computer network subject. It's my passion and it's my love to teach this subject because I love this subject very much. Have been taught this subject from long time. Almost 8 to 10 times I might have taught this subject. So I'm very confident that I will be able to convince you the subject in a better way. And at the same time, I think it's a time for every time when I teach the subject, I believe it is the learning process for me also, and I believe in interaction with the students, I will also be learning much from this complete tenure of discussion of this subject. So now, without wasting much time, I will move on to the subject discussion. Module 4 and 5 to discuss on this. The module 4 is basically on the multimedia networking. I think all of you are knowing that multimedia, the moment we talk about the multimedia, it is the area where the multiple components are considered in the system. For example, the data in different forms is used like the video, audio, text, voice, everything comes into picture. So that's the reason handling this multimedia is one of the great challenge in the network. Because when you push the data, multimedia data in the network, the challenge for you is most of the time it has to run in a real time. When you run it in a real time, definitely the difficulties in the network should not hamper the real time processing. So in order to learn what are the challenges in the networking system and how exactly we can overcome these issues in the networking, we will discuss much in this chapter. I must be thankful to Jim Kuros and Keith Ross. These two are the authors who have written this particular textbook. It is basically a top-down approach. The meaning of this top-down approach is that most of the subjects they will be explaining you the computer networks from bottommost layer to the top, but it is not like that. So from the top layer, I think if you look into OSI model, the top layer is the application layer, and then comes the network layer, and of course host to network layer, and also the physical layer. So this is how they will discuss in this, and hence it is quite different from the regular method of studying, and it is interesting also. I think the PPT is what designed by them is more appropriate to teach this subject, and probably I will be putting some small writing or write up on the slides which you can see later. So that's why I'll be using the PPT of this one. This multimedia networking will be discussing on the basic applications of multimedia networking. And of course, the very important concept, streaming stored video, voice over internet protocol, protocols for real-time conversational applications, and network support for multimedia. I think you need to understand from the application point of view too, the concepts, and also you will be learning how the network support for the multimedia. Right. Let us go with the first topic, that is multimedia networking applications. I think, as you know, in data communications, most of you have learned one of the basic representations of various data. Data will be represented in text form, in the new numbers, and it might be in the video form, or it is in the audio form. Sometimes even the images are also considered. Now the question here is how you represent this audio, video, and the images in a digital media so that the transmission of this data in the network would be more appropriate. So that's the basic discussion here. So let us take the audio transmission in the multimedia. Basically, the analog audio signal is being used, and of course, just a minute. Yeah, I think let me continue with this discussion. The audio signal is basically in the analog form. It is very important you to understand that the audio is read by the mic, and the mic will be reading the sound waves, and it will be an analog signal when it is converted into electromagnetic waves. So this analog signal will be an audio signal as an input, and this most of the time when we used to store it or to make it transmitted to the other side, we have to convert it into the digital form. How exactly we convert that into digital form? As you know, there is a technique called PCM, pulse code modulation. So this is one which will convert from analog to digital. Okay, so the conversion from analog to digital is formed by means of PCM technique. So the same is done here. For that, we have three basic steps. The first step is sampling. The data is supposed to be sampled. You can see that here they have taken an example of telephone audio signal. Usually the telephone audio signal will work at a frequency of 4 kilohertz, and hence the minimum sample rate that is required is 8,000 samples per second. Can you anybody tell me why 8,000 samples per second? The reason is Nyquist theorem. As we know that Nyquist theorem says that the minimum frequency sample rate should be twice that of the maximum frequency. Here the maximum frequency is 4 kilohertz. So 2 into 4 kilo means into 10 to the power 3, that leads to 8,000 samples per second. Okay, so this is how exactly we get these 8,000 samples. And you know, when you used to store it in the CD, so the sample rate will be so high. Okay, it is about 44,100 samples per second it will read. So once you prepare this analog signal into the digital form, then you can effectively store that in the CD. Each sample is quantized and rounded to the 8 bits. Basically, the one sample is converted into 8 bit. So what are the possible quantization sizes? So the quantization size is 256 different levels can be recognized by 8 bit. So it means that a very small 1 divided by 256 is the smallest time period for which you can read the sample, and hence the accuracy is better in this case. So such a quantized value is represented by bits, and these quantized values are represented in the digital form. Here in the figure you can see that this is the analog audio signal. Okay, and hence it is being quantized like this. Okay, so this is the resulting data when it is being captured in the system. Next, you can see that there will be always a quantization error for the basic reason that you can see that any quantization will take only discriminate value. Discrimination means so over a small period there will be a gap, and this gap will lead to the error. It will introduce an error in the data that has been read. Okay, so this error is called as quantization error. The quantization error is more if the sample rate is less. Okay, so quantization error is inversely proportional to the number of samples. More the sample, less is the error. Less the sample, more is the error. Okay, so that's the reason in order to achieve the original signal when it is decoded, it is always necessary for us to go for more number of samples. But it is again a trade-off. It all depends on what quality of signal you are expecting on the other side. So with this, we can discuss about the how exactly the bits are generated and how many bits are generated and how it will be used. You can see here in this example, 8,000 samples are being read, and this leads to 256 different quantized values that will be resulting in 64,000 bits per second. So many bits are generated in 1 second. So the receiver will convert it back into the analog form, and it is called decoding. Okay, the process is called decoding. So in the decoding, there will always be degrade in the quality, which is slightly lesser than that of the original analog signal. And of course, it all depends on the how many samples you read. Now, the storing operation, you can see that the CD has a capacity of 1.411 Mbps, and of course, the rate at which you can store the audio signal in the different coding forms. MP3 is one of the coding techniques that is being used very effectively to compress the audio signal and to store in the storing devices like CDs, compact disc. You can see at a different speed it can store. 96 is one possibility, 128 or 160 kbps. So internet telephony is another kind wherein it will be giving the data at the rate of 5.3 kilobits per second. Let us come to the video. Again, when you talk about the video, video is basically a number of images will form the video. I must be knowing that this can be understood very easily by every one of you because you must have seen the movie Tare Zameen Par, wherein the boy used to scroll the images that are picturized in the small book, so that when he runs the images, it shows that how the boy is going away from his family. Okay, so the movement is visible only when you have the similar kind of images moved faster. So it means that multiple images forms the video, and these images are run at a particular speed to make it more natural and proper motion of the video. Let us see that one. Basically, video is called a sequence of image. That's what I was told you. Number of images, or sometimes these images are also called as frames. Okay, number of frames per second. FPS is the rating we say. The standard rating is 30 frames per second. If you do, probably you can see the video in a very appropriate motion or to the natural motion. I think earlier you might have seen the Gandhiji's video wherein the video will be little faster than what the natural movement of the people. It's because there they were able to capture the image and run back at lesser than 30 frames. It might be 18 frames per second or it might be 24 frames per second. More near to the 30, it will be natural movement can be seen that. So that's how exactly the video is formed. Okay, so the digital video, how the video can be converted into the digital form. Basically, we will read each of the frame as one image, and this image will have the x and y axis data. Okay, it is a matrix data. Okay, there are number of values in this. Okay, these each value will represent one pixel. Okay, so it will represent one pixel, and this is how we can represent one image. So obviously video becomes the multiple copies of the image. So number of such matrices are formed and they are processed. It may look little difficult to understand that see, if there are 30 frames, it means that 30 images run in 1 second and 30 different such matrices are supposed to be used. Okay, so which is a very tedious thing, and of course the data becomes very huge. Okay, that is what is the basic feel of everyone. But here there is a technique. So the technique here is how exactly we decrease the number of bits of encoding the image and reduce the size of this matrix. Size means number of active points are reduced very effectively. So for that we will use two different ways of operation. One is spatial operation, another one is temporal. What do you mean by spatial? Spatial means within the image, within this image, if you make the compression, then it is called spatial. For example, you just separate this part, upper part, okay, this part of the image. Here you can see that if you see this small portion is compared with this small portion, both are having the same yeah, quality of what the colors. So the color is same. It means that this, if you store only this part and you replicate everything here from here to here, that becomes the same color, and you need not store all this area, rather you store only this area and make a replication of this when it is received on the other side up to this part, so that that can be reformed. It means that storing a small part and generating the majority of the image will reduce the amount of bits that are required to store this image. So the same kind of process goes from top to bottom, and it is called spatial compression. The compression is made in the spatial area. Spatial means in the x and y coordinate. Any image will give us x and y coordinate. But there are opportunities, or the more amount of compression is possible in the video because of its very nature. The video is formed by number of images. So we say it is the third dimension. Number of images are in the third dimension. Okay, so when you have the comparison from one image to the another image, that becomes temporal. Okay, that becomes temporal because on the time axis we are considering the different frames that are generated. Now what we do in this case to make more compression is, see, the different frames will be compared each other. For example, this frame is compared with the next frame, because we told that 30 images are captured in 1 second. So the difference between one image to the another image in that will be very, very less. Probably you can see the best example I can tell you is that when the news reader is reading, hardly they will do very minimal movement. For example, they will be reading like that. Most of the time their lips movement will be there, and eyelid movements you can see. Sometimes the other part of face can also be changed. So it means that when such a change takes place, only that part has supposed to be encoded, and the remaining background and other part of the face and the body, what is visible in the image, can remain the same. So in that case, definitely what we can do is, in the next images we will be encoding only the portion that is being changed, and hence we say that, so this portion of image will be encoded, the rest will be mapped to the previous image. Okay, like that. So number of images, only the area which is being changed, or the change from one image to another image happens, that will be go on changing. The rest part remains to be the original. So that is why the original image is called I means information. Further, we will develop the images by means of PPP, predictions. Okay, what is the change from here to here that has been identified, and this can be developed by the prediction of with the I. Then there will be B is another frame that we use to encode, and it is called bidirectional. So it may be compared with the previous and also the next image. So that time the comparison becomes easier. So this is how exactly we do the comparisons, and hence the video compression will be very, very high when it comes to the temporal. Okay, so you can see that the spatial coding will reduce to some extent, and when you do what the temporal encoding, then the compression will be very high, and hence the number of bits that are required to encode the video will be reduced to a great extent. You must be knowing that there are standard encoding techniques which will be encoding with a very high compression ratio. For example, the image compression we do with JPEG, GIF format is there. Okay, PIG format we say. Okay, all these will compress the image in the spatial area. But when it comes to the video, we use the MPEG. MPEG stands for Motion Picture Experts Group. So this is one of the encoding technique where both spatial and the temporal compression is done, and hence it is going to be more effective. So there are a variety of video encoding techniques are there. One we basically called as CBR. CBR means constant bit rate video encoding. It means that the bits will be generated constantly. Okay, so it's very difficult to achieve, but so this is the one which will ensure more quality of service. Okay, so in the constant bit rate, what happens is the bits that are generated from the video will be generated at a very constant rate. For example, 50 kbps, 50 kilobits per second, or otherwise 1 mbps, 1 megabits per second. That could be the constant rate. But more oftenly, it is a possibility that the bit generation will be variable, and hence we use variable bit rate. Here, the amount of spatial and temporal coding changes are more. Okay, for example, you might have seen the jogger's video. Jogger video means a person who is jogging in front of the background nature will make a lot of changes. The background is also changing, and also he is moving from one point to another point. Obviously, a big changes in the what the each frame will can be captured. One frame to the another frame, there will be a great change. So this change is supposed to be encoded. That's the reason the change is not constant. It will vary from one frame to another frame, and hence variable bit rate is essential. Some of the standard techniques of encoding are highlighted here. MPEG-1, there are different versions of MPEG there. As I told, MPEG stands for Motion Picture Experts Group. The MPEG-1 is the earlier version where it was using it for the CD-ROM, compact disc read-only memory, which will be generating the bit rate of 1.5 megabits per second. Later, we have come out with the MPEG-2. I think DVD has come into picture. Digital versatile disk, where up to 6 Mbps we can able to generate the bits. Later, we have, I think even today we are using more oftenly MPEG-4. Of course, MPEG-5 has come, but MPEG-4 remains to be the most standard. Here, it can be used in the internet, and which can go up to 1 Mbps. So these are some of the techniques that are being used to capture the video. Now coming to the different applications of multimedia. The first one is streaming the audio and video. I think you must be knowing that there are some standard storing agents or agencies are there. For example, you have seen YouTube, you have seen Netflix, Hulu, and Amazon Prime, like that. So where they maintain the videos and in their server only. Okay, what we do is we will be streaming it as and when it is required. There are two ways of streaming. One is live streaming, another one is stored streaming. If you look at the stored streaming, you see that this is the streaming can begin the play out before downloading the entire file. It means that it will be downloading the file, and parallelly it will be playing it back. Okay, that is one way. The other way is we download the complete image, video, and then we will play back. So in that case, it is very easy where you will store it and then you will play it back, because once you store, playing it back will be very smooth without any buffering. So buffering is one of the major problem in the live streaming. You can see that the stored videos can transmit faster than the that is being rendered in the client side where it is buffered. So these are some of the examples. So the other one is conversational voice video over IP. I think most of you are very much familiar with the Skype. Nowadays we have the other applications rather than Skype. You might have heard about the due to this pandemic situation and lockdown case, we have evolved with lot many applications. You have Zoom application, you have Microsoft Teams, we have Cisco WebEx, like Joho is also there. Like that, many applications have been evolved. So these are all used as conversational voice and video over the internet protocol. So here there is an interaction of different people is possible, where the tolerance of delay is very much limited, because I am speaking to you, you should immediately receive my video and audio, and so you will be responding to it, and I should also read it in the real time. Okay, so it is more often it is a real time communication. Okay, so in that case, obviously the video is audio video has to be transmitted at a real time, which is again a challenge for us. And the third one is live streaming. I think you must be knowing that whenever a cricket match or a football match is going on, then you will be watching it live. It means that what is happening on the other side can be viewed here on live. So here also streaming is very difficult, because so whatever is happening is supposed to be telecasted immediately, and if there is any delay, that leads to so much of inconvenience for the receiver. So it is the third way where the protocols, the technology that is being used to make the transmission of such a video, audio is supposed to be very important. And here the quality of service plays a very important role. What is meant by quality of service? The what we are receiving the video should be able to be conveniently watched by an audience. Okay, so there should not be any buffering, there should not be any delay in displaying the frames of the video, there should not be any break in the audio. Then we say it is a good quality video. So in order to maintain the quality of service, we used to use different techniques and also protocols for that. However, it is not the part of discussion in this, so let us not discuss much on that. Right then, I will stop here. In the next class, we will be discussing in detail the technology that is being used for the streaming of stored video. Okay, right then. Thank you. Thanks for joining.